Okay, so let's take a look at 4.5 using quadratic models to solve problems. Now, it says here if you're given something in standard form, obviously you can change it to vertex form. Why would you need something in vertex form? Clearly, if you're ever trying to look for a maximum or minimum, vertex form will tell you what the maximum or minimum is. If you're looking for the zeros, or when an object hits the ground or something like that, if you're ever looking for the x-intercepts, the easiest way to figure that out is by either using the quadratic formula, and it will give you the x-intercepts immediately, or you can factor and find the zeros that way. So let's take a look at example 1. It says the function p at x equals negative 30x squared plus 360x plus 785 models the profit p at x earned by a theater owner on the basis of a ticket price x. So p at x is the profit and x is the ticket price. Both the profit and ticket price are in dollars. What is the maximum profit? Okay, so what is the maximum profit and how much should the tickets cost in order to have the maximum profit? So clearly we are given this formula, and this formula is in standard form. Okay, so you have two options to figure out the maximum. Again, if this is your formula in standard form, you have two options. You can either complete the square, but nowhere in this problem does it say that you have to complete the square. So you can either complete the square, or you can use that formula of x equals negative b all over 2a. And remember, this is the formula to figure out the equation of the axis of symmetry. Why is the equation of the axis of symmetry so important? Because it tells you exactly where the vertex is located. So I'm going to plug it in here because this is much easier. X is equal to negative b, so negative 360, all over 2 times a, which is negative 30. So x is equal to negative 360 divided by negative 60. And if you do this, x is equal to positive 6. So I know that the vertex of this thing is definitely 6 something. I don't know what the height is, but I definitely know that my x value is 6. I have to figure out my y value. Okay, or instead of y, it's p at x. So what is the maximum profit? It happens when x is 6. And remember what x is the ticket price. So we already know that the maximum profit happens when the ticket price is only $6. So let's figure out what the maximum profit is by plugging it in here. So this is p at 6 is equal to negative 30, and then you're going to have 6 squared plus 360 times 6 plus 785. Okay, so remember your rules when you go to do this. Don't multiply the negative 30 by 6 first. You have to obviously do the 6 squared first. So this is negative 30 times 36. Okay, and then you have 360 times 360 times 6, and that will give you 2,160 plus 785. If you continue this, you're going to have negative 30 times 36, which is 30 times 36 is 1,080. Let me just double check this answer here. 360 times 6, yep, that's perfect. So that's negative 1,080 plus this plus this. So you have p at 6 is equal to, and now if you add all these things together, you got 2160 plus 785 minus the 1,080, and you have a total of 1865. Okay, so I know that the vertex is 1865. So that means, therefore, the max profit is $1,865 and it happens when the ticket price, or happens at ticket price of $6. Okay? So again, this asks me for a maximum. If you ever hear maximum, that is asking you for the vertex, no matter what. Okay? If it's asking you about the zeros, when will profit be 0? Well, then you would have to use either the quadratic formula or factor. But this is asking for a maximum, so you have to find the vertex. That's the easiest way to find the vertex rather than complete the square. So let's take a look at the second example here. The second example here, it states the height of a soccer ball kicked in the air is given by the quadratic equation h at t equals all this stuff. Okay? Now it's very important you see that this is given in vertex form, okay, where t is time and it's in seconds and height is in meters. What is the height of the ball when it was kicked? Well, if you're ever trying to determine the height of the ball when it was kicked, it's kicked at time 0. So all I'm going to do is I'm going to plug in what's the height at time 0. So if I plug this in, it's going to be negative 4.9, and I'm going to have 0 minus 2.1 all squared plus 23. Continuing this is height at 0 is equal to negative 4.9, and in this bracket I'm just going to do this in one shot because that's 0 minus 2.1 and square that. So 0 minus 2.1 is negative 2.1, and if I square negative 2.1, it gives me 4.41, and then I have plus 23. And so height at time 0 is equal to, now I will multiply these two numbers together. So I should get negative 21.609 plus 23. And if I continue this, height at time 0, if I add those two things together, I'm going to get approximately 1.391. So the height of the ball, or the height, of the soccer ball when it was kicked was 1.391. It wasn't 0 because obviously a soccer ball can be kicked in midair. So that is definitely the height of the soccer ball. Again, you got to understand what the question is asking you to do. The question is asking you to find what the height of the soccer ball was when it was kicked. So when it was initially kicked, that's time 0. What is the maximum height of the ball? Well, we know the vertex because the vertex is already given to us. It's in vertex form. The vertex is 2.123. Okay? So the maximum height of the ball is 23, and it happens at time. So this is height and time. The maximum height is 23, and it happens at time 2.1 seconds. So the max is 23 meters in the air. That's how the maximum height that ball will hit. Is the ball still in the air after 6 seconds? So is the ball still in the air after 6 seconds? So how would you do this? Well, and it asks us to explain. So obviously this is a type of communication problem. So if you take a look at this and draw a picture for yourself, and here's time and here is height as a function of time. If you draw a quick picture for yourself, you know that the ball was kicked at about 1.391 meters. Okay, it's kicked in the air, it does this, and then it comes back down and it lands somewhere there. Now you know what the vertex is. The vertex being 2.123. Sorry about that. So you have 23, and this is happening at exactly 2.1. Okay. Now, if you take a look at this and it asks you, is the ball still in the air after 6 seconds? Well, you kind of have to take a look at this drawing here. See, from here to here, so if we're talking about the same height, 1.391, and obviously 1.391 again, the distance from here to here is 2.1, so the distance from here to here is 2.1, so this is 4.2, so that's 0, 2.1, 4.2, and this is when it hits the ground just after 4.2. So is this going to still be in the air 6 seconds later? And the answer is no, it's not, because of this picture. Otherwise, what you can do is plug in 6 seconds for time. And if you do that, you're going to get negative 4.9, and then you'll have 6 minus 2.1, so this is just using that formula up there, and this is squared plus 23. And if you continue this, height at 6 is equal to negative 4.9, and when I do this here, this is 6 minus 2.1, which is 3.9 all squared, plus 23. So height at 6 seconds is going to be equal to, remember to do the square first, so I'm going to do 3.9 all squared. 3.9 all squared, which is, so this is negative 4.9 times 15.21 plus 23. So height at 6 seconds is going to be equal to, I'm going to multiply these things together. So I get negative 74.529, and I still have plus 23. So if I add 23 to this, I'm going to get height at 6 seconds is equal to negative 51.529. And clearly, how can the height of the soccer ball be a height of negative 51.529? That means it's through the ground and underground. And clearly we know how a soccer game happens. You kick the ball in the air and it's going to bounce on the ground. So clearly no, it's not in the air after 6 seconds because it's already bounced. Okay, it doesn't go underground. It's not in the air anymore. Then question D, when is the ball at a height of 10 meters? So again, I have height as a function of time is equal to 4.9 t minus 2.1 all squared plus 23. And I want to know when the height is 10. When the height is 10, not when time is 10, when the height is 10. So I'm going to plug in 10 in for height, and I'm going to solve this thing algebraically. So remember, this is in vertex form, so I can solve this algebraically. I can solve for t by isolating for t. So I'm going to bring the 23 over to the other side first. So 23 to the other side will be negative 23. I still have negative 4.9 t minus 2.1 all squared. And then I'm going to do 10 minus 23, which is negative 13, minus 4.9 t minus 2.1 all squared. And then the next step I'm going to do is I'm going to divide both sides by the negative 4.9. So divide both sides by negative 4.9. That will get rid of it on this side. So I will have t minus 2.1 all squared on that side. And on this side, I'm going to do negative 13 divided by negative 4.9. And I'm going to get roughly positive 2.653. There's more decimal places than that, but I'll just leave it at that. And then to get rid of the square, I have to take the square root of both sides. So I get t minus 2.1 on this side. And over here, I get plus or minus. When I take the square root of this number, I get plus or minus 1.629 approximately. And so I now bring the negative 2.1 to the other side. This will be plus or minus 1.629 plus 2.1. Okay, and now I have to break this up into two answers. I have t is equal to positive 1.629 plus 2.1, or I have t is equal to negative 1.629 plus 2.1. Over here, when I do this, I'm going to get roughly that plus that is 3.729. T is equal to 3.729. So there's one of my answers. And then the second answer, if I add those two things together, I'm going to get positive 0.471. So there are two instances that the ball will hit 10 meters. The ball will hit 10 meters first at 0.471 seconds and then later at 3.729 seconds. You end up with two answers where it hits the height of 10 meters.